Okay, so we will start with the lecture. So yesterday I had given some tasks. So I will just take a review of that before we start the lecture. So what task I had given yesterday? Can anyone tell? Refractive index formula. Okay, so let me first listen from the online students. What is the formula for refractive index of any media? Yes, give the answers, please. And one thing I want to announce from your list, those who have joined, if you have given the elective as sensor and network, that another subject, and if your list is, if your name is in that list as per the choices given by you to your class coordinator, then you have to join that subject only. And for any change, you have to discuss with your CC and HOD. Otherwise, unnecessarily attendance will be marked as absent in the respective subjects which are given on paper. Okay. So, what question I had given? Refractive index of any media. Can anyone give the answer for the question? Yes, online.
N is equal to C divided by V.
Okay. What is C?
Speed of light.
In which media?
Optic fiber.
Just check that formula once again, Audumbar.
Okay.
What is this side? What is the formula for refractive index of any media? Speed of light divided by phase velocity. Okay, this side. नाही बघितलं सागर. Okay, Vaishnavi. Vaishnavi, na your name? Okay. First assignment, first task I had given and you have not completed. Okay, so that speed of light, any other person is able to tell answer for this question? Refractive index of any media? Yes, Omkar. So I will just write here by minimizing this. So refractive index of any media we are calculating as speed of light in air. So speed of light in air divided by speed of light in the particular medium. For example, if we have to find the speed of light in glass. So refractive index is equal to the velocity of light at given wavelength in empty space divided by its velocity in the substance. Yes, that is correct. Okay. So I will just write here just for your understanding. Don't relate it with this particular topic. So refractive index, it is represented as small n. The notation for refractive index is small n. So it is given by basically C. C म्हणजे काय? Speed of light in air. And what is that value? Speed of light in air किती आहे सांगा मला? Speed of light in air 3 into 10 raised to 8 meter per second. Okay, you can write down simultaneously. Refractive index is equal to speed of light in air, that is C, and which is equal to 3 into 10 raised to 8 meter per second divided by speed of light in particular मीडियम. म्हणजे ज्या मीडियमचा रिफ्रॅक्टिव्ह इंडेक्स आपल्याला कॅल्क्युलेट करायचा आहे त्या मीडियम मध्ये लाईटचा ट्रॅव्हलिंग स्पीड किती आहे. सो अँड दॅट यू कॅन ऑल्सो नोट इट ॲज स्मॉल व्ही. सो एन इज गिवन ॲज सी डिवायडेड बाय व्ही. नाव यू टेल मी, इज दिस फॉर्म्युला क्लिअर? फर्स्ट, speed of light in air divided by speed of light in a particular medium. So from this formula Can you tell me what is the value of refractive index of air? Air has medium आपण consider केला. तर what will be the refractive index of air? Formula समजला का हा शेफाली? Formula is clear. Speed of light in air divided by speed of light in particular medium. म्हणजे समजा आपल्याला आता refractive index of glass calculate करायचं आहे. तर how you will calculate? Speed of light in air divided by speed of light in the glass. So you tell me what will be the refractive index of air? How you will calculate? Yes. Anybody from this online side? What will be the refractive index of air? Very simple. This formula you have to use. Just medium you will substitute by what? Again? आपण काय calculate करतोय? Please try to understand. This formula is clear, Sagar. Speed of light in air divided by speed of light in a particular medium. Then when I say speed of light in air only I am considering as a medium. मग हा formula कसा modify होईल? Refractive index of air is equal to speed of light in air divided by again speed of light in air. That's why always you remember the speed of light in the refractive index of air that is noted as symbol as N0. Okay, so I will write here. So actually at its bottom side it is having. So speed of light in air N0 is equal to 1. हे सांगितलं आता. आता मला सांगा, another question I have asked you, that always refractive index of any solid material will be greater than 1 or less than 1 or equal to 1. हा N0 1 आला हे समजलं सगळ्यांना. मग सांगा आता, if you have to calculate the refractive index of any solid material, you consider any glass or any other solid material, then that value will be equal to 1, greater than 1 or less than 1. आता suppose speed of light, suppose we are calculating the refractive index of glass. How you will calculate? Speed of light in air divided by speed of light in the glass. So speed of light will be more in air or it will be more in vacuum. It will be more in the glass. लाईटचा स्पीड ओपन स्पेस मध्ये जास्त असेल का सॉलिड मीडिया मध्ये जास्त असेल? ओपन स्पेस. सो ऑलवेज speed of light in any solid material will be less than its speed in the air. So this numerator will be greater and denominator will be small. So always the refractive index of any solid material will be what? Greater than 1, less than 1, equal to 1. Give answer.
Ma'am, I think greater than.
Yes, it will be greater than 1 always. You can check. For example, I will just show you here this refractive index. Here you can see refractive index of glass. See, it is around 1.63 or 1.49. So it is greater than 1. Glass is a solid media. Again, liquid media also, if you see refractive index of water, it is equal to 1.33. Again, I will say refractive index of any here glycerin it is given. So it is 1.46. So though it is solid, liquid or semi, like not exactly solid or liquid, still it will be always greater than 1. It will be never less than 1. तुमचं जर न्यूमरिकल सॉल्व करताना रिफ्रॅक्टिव्ह इंडेक्सची व्हॅल्यू 1 पेक्षा कमी आली तर you have to understand that some mistake is there in the calculation. Okay, so refractive index should be greater than 1. So this is the basic formula of refractive index. So is it clear to all? So this formula you have to use for solving the numerical. म्हणजे एखादा मटेरियलचं स्पीड ऑफ लाईट in that particular medium it is given and you are asked to calculate the refractive index. This C value will be constant always. 3 into 10 raised to 8 meter per second. आणि ह्याचा जो स्पीड दिलेला असेल, you have to divide the C by that particular speed and you will be able to get the value of N. Okay. So this task I had given you and that's why always the refractive index of any solid media is greater than 1. So I hope you are clear with this. Clear? So yesterday we have seen the advantages of optical fiber communication. High information carrying capacity, resource plentiful, less attenuation, greater safety, immunity to radio frequency interference, immunity to EMI. Then next, no crosstalk, security, small size and less weight, less corrosion, less temperature sensitive. So these are the advantages of optical fiber communication. So any other task I have given? I had told you to find out the formula which is giving the relationship between frequency and wavelength. Done or not? Yourself? Okay, this side. Have you completed that? Formula search केला का? Yes, Aarti, Sanjana. So what is the formula? Frequency and wavelength. What is the relation? Directly proportional, inversely proportional. Inversely proportional. Okay, so again I will write here the formula that frequency. So frequency of any signal multiplied by wavelength of that signal, that gives you the speed of light in air, or I will just write here frequency into wavelength is equal to C, that is speed of light in air. The standard formula you remember and note it down. एखाद्या न्यूमरिकल मध्ये कधी कधी डायरेक्ट वेव्हलेंथची व्हॅल्यू न देता दे आर गिविंग द व्हॅल्यू ऑफ द frequency. So from that frequency value, you have to calculate the wavelength by using this basic formula. So this C is what? C is nothing but 3 into 10 raised to 8. 3 into 10 raised to 8 and unit it is meter per second. Suppose calculators you have. So hereafter please have the calculators with you because we have to solve various numericals in this subject and those are simple one, but you require calculator for that. Suppose now the frequency is 1 kilohertz. एखाद्या सिग्नलची फ्रिक्वेन्सी दिलेली आहे 1 kilohertz. 1 kilohertz is the given frequency of the signal. Then what will be the wavelength for that particular signal? Can anyone tell? काय करणार तुम्ही? C divided by 1 kilohertz. So what will be the wavelength? Are you able to calculate what I told? Frequency is given as 1 kilohertz and you are asked to calculate the wavelength. So tell me what is the answer for this question. Three into 10 raised to 8 divided by 1 kilohertz means 1000. So how much will be the wavelength? Wavelength is having unit as meter. Frequency is having unit as hertz. Wavelength is having unit as meter. So you have to do that. 3 into 10 raised to 8 divided by 1 kilohertz, that is 1000. So tell me the answer. You don't have calculators? This side. Audumbar, can you give the answer? Okay, so if you don't have calculator, try it at home at least. 3 into 10 raised to 8 divided by काय येईल इथं? 1 kilohertz. Omkar, am I audible?
Yes, ma'am, but calculator नसल्यामुळे मी.
Yes, ma'am, audible.
Okay. So hereafter you please keep it with you for lecture.
Yes, ma'am.
So these basic things I have to take first. So now we will go for the next part, that is disadvantages of optical communication. So or we can say that are nothing but the limitations of optical communication. So first disadvantage, it is bending loss. So obviously when the optical fiber cable is bent, the losses will take place. It is very simple. If optical fiber is straight, the amount of information passing through that will be more. Whereas when it is bent, it will be reducing the amount of optical power coming from that particular fiber. Apan simple example घेऊ शकतो. Water pipe, you know, if it is bent, obviously the amount of water coming at the output, it is reduced. Okay. So first disadvantage is bending loss. So bending losses, optical fiber when it is practically used, it is bent number of times. So bending losses are taking place in the optical fiber. That is the first disadvantage. Then second, splicing loss. Splicing means what? Joining. Optical fiber joint मध्ये दोन types आहेत, splices आणि connectors. So splices stand for the permanent joint of two optical fiber. So when two optical fibers are permanently joined, that is called as splices, and during that splicing process the losses take place. This part in detail we are going to see in second chapter. So suppose this is one fiber, it is having core and cladding, and suppose this is another fiber that is having core and cladding. So both are having different refractive indices, both are having different material. त्यामुळे joining करताना काय होतं, many times during the joining of two optical fiber cables the losses take place. That is called as the splicing losses or joint loss during the joining of optical fiber, and that can be minimized by using which method, that also we are going to see in the second chapter. This is the second disadvantage. Then third disadvantage is it cannot work in the field of gamma rays. So in the presence of gamma rays, where the gamma rays are present in the particular application, these optical fibers are not able to work properly. So they get decolorized, or some functional defects are coming in the optical fibers structure, and they are not able to operate properly. Then next disadvantage is it cannot work above the 30,000 volt. Means wherever very high above this voltage ranges are there, they are not able to work. Then next, slow standard development. So this meaning of this particular term is in the history of optical fiber. So here you can see. So as per the comparison with other devices, development speed was somewhat less. That is the meaning of this point number 5. Slow standard development. Development speed was somewhat less in the optical fibers. And then next disadvantage is is still some optical devices, they are having the high cost, like laser. If you compare LED and laser, LED chip कधी कधी ऍडव्हान्टेजेस मध्ये लो कॉस्ट देतात आणि डिसएडव्हान्टेजेस मध्ये हाय कॉस्ट. So that statement seems contradictory, but that is varying because of the devices. If you are selecting LED for your project, that will be low cost. If you are selecting the laser, that will be the high cost. So depends on which device you are selecting, the cost of the optical communication is going to change, either low or either high. So these are the disadvantages of optical communication system. Okay, so based on this point, the question it is asked. So sufficient time we have given for that particular point to discuss. Now these are the applications. So applications where the optical fibers are used: telecommunication, that is for long distance transmission, inter-exchange junction, fiber in the loop. So these are the general applications in telecommunication. Then next, video transmission. So in video transmission, the optical fibers are used for television broadcasting, cable television, remote monitoring, etc. So these are the applications related to video transmission. Then broadband services, providing the broadband services such as video request service, home study courses, medical facility, etc. So these are the broadcast services application of optical fiber. High EMI area म्हणजे जिथं electromagnetic field is very high range, there also we are using the optical fiber along the railway track, then through the power substations, जिथं MSCB चे किंवा जिथं high power areas असतात, there to use the coaxial cable that is somewhat risky. So there we can use the optical fibers. Whether the optical fibers are carrying the electrical current? Yes. Whether optical fibers are carrying electrical current? Yes or no? They are not carrying because they are totally free from the electromagnetic interference or any electrical signal, because they, in the optical fiber, basically information is transmitted in the form of light. Okay, so that's why they can be used in high EMI areas. Then next is military applications. So for the military application, non-communication fiber optics, that is fiber sensors, they are used. So these are the general applications. And now, as I said that previously also I have given so many examples. If for some particular questions, answer is not unique, you may get multiple applications when you will search on the internet or you will read in another book. So these are the basic applications you can consider for optical fibers. You just give the heading as application of optical fiber communication system, and whatever is that red highlights that you can write. Okay, there is one session for you at 3 p.m. and you have to attend it. So those who are joining online, give your attendance, put your roll number and division in the chat box.